Last week, while we were looking at the Olympic and Paralympic Museum project, I was really struck with the visual complexities of the structures that were behind it, and I really felt like there was more going on here, more complexity than there really needed to be, and that set me off to thinking. Part of it, I believe, is the way that the groups are working together to create structures like this. You have a structural engineer who's creating the structural system. You have a vendor who's creating the facade components, the radius track. And there's very little integration between the structural components as they move through the building envelope. And that may change. That may be just the nature of the beast. But one of the comparisons I wanted to bring up, and is historical, is we used to design automobiles where we put a body on top of a chassis. And this is a really poor visual to actually use to discuss this content, but I really couldn't find anything else that would develop more clarity. But here we have, the 1970s, 1960s version of how an auto body was created. We had suspension components, and then we took a whole finished body and attached it to the chassis. Well, today we no longer make automobiles that way. We make what's called a unibody construction, which means that the whole automobile is considered as part of the structural components that give structure to the vehicle. So there's some really important advantages to that. One is that these actually perform better. They reduce the amount of weight that's needed because now there isn't this underlying structure. They're more crash worthy because we have engineering controls over the way the energy is distributed through the cabin in the event of a crash, and all kinds of higher performance tolerances with the way we can create these assemblies. So there was an evolution in our auto industry, and I don't think that's unlike what's probably going to happen in our architectural construction techniques. And as architects, I think we need to be cognizant of that. I think we need to visually see this as troublesome and then think about, are there ways that we can think about enhancing or resolving these kind of complexities for the betterment of the project, and that goes forward. I'm always kind of also stepping back to think about what we're doing in 8753. I think we're gonna move through this week looking at steel, specific materiality. We're gonna also look at glass and wood. We spent a lot of time thinking about facades, and then the methods that we manufacture, and then obviously one of the key words in our course name is structure. Form as exposed, form as the generator of structure. And anyway, I think it was just important. It's important for me to continually go back to this idea that there's a lot going on, a circular nature to everything needing to, I guess, always aspire to a better integration, to a more simplified, uniform, and still creative expression of our architectural aspirations. So while it may appear on the outside that we're jumping from subject to subject, I think it's important to step back sometime and look at the bigger picture on the concept of the overall integration of these components for better products. A couple of reviews of this week's project. This was Caleb's project, and he mentioned something down here, and I wanted to mention or reiterate it. He goes, is a way of improving the project, that it would be a greater benefit if it also demonstrated how to create massings that could serve as actual building forms, as well as some to create a parametric frame that would eliminate the need to create custom framing of varying dimensions. And the issue I wanted to mention or point out was we're really not creating custom frames of varying dimensions. While I agree with the idea of more form exploration as a building form, and you'll see another example of another student's work. The idea that I really want us all to hold on to, though, is that the shape, this back form that we're creating, is really an adaptable structural component. No matter how we reshape our facade, and it's something we really didn't experiment enough with, this parametric assembly will always reconfigure to it. So we are already creating a parametric relationship between the frame and the surface. And probably the shortcoming of the project was not to do more experimentation with that. So I apologize for that lack of rigor in that part of the project. And then obviously this was a really delightful project to get. This was an expansion on the concept of this adaptable form. So here we have actually now the adaptable form carried out. And just obviously this project got my first 10. Not just because of its creativity, but just because of the extraordinary amount of effort that went into this one. So my hat off to Micah. Here we have probably just something to connect us back, especially to this idea of the stadium and what we were doing with facades. I wanted to point out that while this is the start of the generation of stadium facades and this kind of like secondary skinning of buildings, the Barclays Center is a great example of skinning a very common form, a stadium form, in a way that really completely reinvents what the form looks like. This was done by shop architects, and this is I believe a Core 10 steel, kind of rusting. This is in Brooklyn. They were called in actually late in this project to help create a facade for this building because the other ones weren't actually winning community acceptance. But what's important to see in this is obviously now we're in this idea of form shaping, and now we can understand how then these parametric or these elements are applied to those surfaces. And then most importantly, this idea, I think you can see this back substructure, and I think you can understand now how we can have a form, then these other layers underneath with a lot of complexity and still be relatively easily understood in our modeling techniques. So we can think about making our form do anything it wants and then carrying it back to commonality, common points within the building structure to make our attachment with these truss systems. And then we'll pick up in the next one on customized repetitive manufacturing.